Okay, we're going to start looking at the lesson 1.4 notes, and then, in all honesty, we'll plan most likely to finish them tomorrow. Just working with functions. It's review what we're doing. That doesn't mean it's a fun, exciting thing that we are great at, but it's review. So we're going to start at the top, start with some easy stuff here. Combination of functions. What you are looking at over here at the left. Okay, right here. These are some basic rules about functions. And what these basic rules say, so here, if you're asked to find f plus g of x, then that means you're going to take f of x and add it to g of x. In the same sense, if you're asked to find f minus g of x, it's the same thing as saying f of x minus g of x. If you're asked to find f g of x, that's saying you multiply f times g. And if you're asked to find f over g, that's saying you divide f and g. So very basic there, nothing fancy, nothing crazy difficult. Okay, you're just asked to do whatever it says. So in example 1, it defines f of x as x squared and g of x as the square root of x plus 1. And then they ask us to find 4 different things, right? So let's start with the fact that they ask us to find f plus g. So when they ask us to find f plus g, my official notation would be f plus g of x. What are your thoughts about f plus g of x? Take the easy one while you can, guys. It is easy. What's f? X squared. What's g? Square root of x plus 1. So what's f plus g? Yep. X squared plus the square root of x plus 1. Can I add that any farther? No, I can't. I'm done right there. X squared plus square root of x plus 1 is just that. Okay, so if that's f plus g, what about f minus g?
X squared minus the square root of x plus 1.
Okay. X squared minus the square root of x plus 1. Can I do anything else with that? Can't do anything else with it, can we? We're done right there. Okay. So, who's going to take a try now at fg? They asked us to find fg of x. Who's going to take a try at fg? I feel like Dayton wants to try it.
Is it x squared just times the square root of x plus 1?
It is.
Oh, okay, that was easy.
X squared times the square root of x plus 1. Can I go any farther with that? No, I can't. I don't want to multiply an x squared into a square root. That doesn't make sense. I can't take the square root of x plus 1. Now, am I saying that these, when you do an f plus g or an f times g, things will never simplify? I'm not saying that. They do sometimes simplify. But in these particular cases, there's nothing simplifying there. Last one. F over g. Thoughts? Uh-huh. X squared over the square root of x plus 1. Now, depending on your mood, depending on the expectations, I shouldn't say depending on your mood. It just has nothing to do with your mood. I know what you guys are going to do. You're going to leave it like this, aren't you? And you're going to be nice. You can leave it like this. But what might you be required to do in a problem like this? Yeah. Remember, technically, it's not proper form to leave a radical, a square root in the denominator. So sometimes you might be asked to rationalize it is the word. Now, good news? We're not going to rationalize. We're just going to leave it like that. Don't complain there, right? And I'm trying to remember off the top of my head if there's any like that in homework. Yeah, they don't rationalize anything in homework. Okay. So you're good there. Okay. That was the easy peasy stuff, right? Piece of cake there. Where are we at on time? Let's go ahead and start talking about composition of functions. When I talk about composition of functions, this is when I start talking about fog. Not the fog out there that you might see with the rain, but f composed with g of x. And so, when we talk about composition of functions, f composed with g of x. So, it's a composition circle because there's a open circle, unlike a multiplication dot that would be filled in. And that means when we do this, we're going to do f of g of x, which, note what it says, plug the entire function of g into f of x. So if you're doing f of g of x, we take whatever g is and plug it into f. Okay? So, and we're actually going to talk about fog, so f composed with g, and we're going to talk about goff, g composed with f, which is just reversing how you do this. So, let's look at what I refer to as fog. Which fog, f composed with g of x. And one of the first things I always do is I rewrite this. F of g of x. So, I might take a step in between here. You can jump to the final answer. F of g of x says I'm taking whatever g of x is, and I'm plugging it into f. So look over here. F is e to the x. G is the square root of x. I'm going to take g and plug it into f. And if you want, you can think about as writing it to begin with as f of g is the square root of x. I don't know if that helps if I write it like that or if that just doesn't help or confuses. I don't want to confuse, but so this is saying we take g, which is square root of x, and we're going to plug it into f. Thoughts on how that's going to work? Every place I see an x in f, I'm going to replace it with square root of x. So f, instead of being e to the x, it's going to be e to the square root of x. And that's it right there. Questions on how I did that? I know from past experience, doing this fog and golf stuff is not our most favorite activity. It's not the most understood thing, but it is necessary. Okay, we do use it at various times and places. My calc kids are finding that out that they use it. So it's definitely something that sticks around. Now, let's reverse this. They also asked us to find goff. So if I'm going to write this out, goff means instead I'm going to say g of f of x. Thoughts on what that means? Whatever f is going into g. What's f? E to the x. So that means e to the x is going to go into g. What does that look like then when I put that into g? Since f is going in, so e to the x is going into g, and it's the square root of whatever x is, so it's going to be the square root of e to the x. So a point to make there is a difference between fog and goff, right? Whether it's f of g of x or g of f of x, it's not like multiplying or adding or subtracting. Well, I shouldn't say multiplying or adding where it doesn't matter the order. Order does matter here. Okay? When you look down at the next section, and we'll talk mostly about this tomorrow, but the other big thing we're going to do is we're going to continue to talk about domain. So we're going to continue to work on that understanding of domain. And they're asking us to find the domain of fog and goff, given these two new things. So the first thing you're going to have to do to find the domain of fog and goff is you're going to have to find fog and goff. So tomorrow when we start class, that's what I'm going to start off asking you guys to do. Is I'm going to ask you to find fog and goff, and then we'll go through domain together, obviously. Okay? So homework is out there. You're welcome to start looking at it. You can probably do a little bit at the beginning.
First question is already asked to find the domain.
Okay. And is it, I'm trying to remember.
We've already tried to find fog and goff.
Okay. And we'll talk. So we didn't find domain up in that top set, but we'll find domain in some of these others to practice it. So you can still do the rest. You just will have to go back and do fog and or the domain, I mean.